the one that I did in the task was quite simple. It was just really two one up, one down kind of thing. Or what was it? Yes, one. I can't even remember what the directions were, but it was you already had the total red one, if I could say, and then the total blue one. So you just had to find the results into there. But these we now are going to look at. Oh, my cat's here, I might be disturbed. Okay, he's just walked in through the door. Okay, so number 8 says 25 newtons up, 40 newtons down. Just follow me and make sure I'm writing the right one. 30 newton. Oh, see now already I'm doing something wrong. 30 newtons right and 50 newtons left. Please tell me that is number 8. I'm going to just pull this. Damn it. Sorry, girls, I've just lost the Vimeo for a second. You're full of dust, cat. This cat loves to roll in the sand when he comes and stands on the road. All right, so we've got 25 newtons up. So let's draw it. So if we go 25 newtons up, so remember we do a little bit of a Cartesian plane. Remember, girls, you don't have to draw like a ruler. You don't have to put all the numbers. So you can literally just draw a basic little Cartesian plane like this, and we're going 25 newtons up, and you can label it like that. Now, when I ask you to draw a diagram, and I'm going to teach you how to draw a free body diagram next week, you're going to then show it like that, and you show a dot, and you're going to show the 25 over there and the 40 over there. So don't worry about doing it like this yet. I'm going to show you how to do this now. But when you're going to calculate, this is what I want you to do on a Cartesian plane. So you can put another one over there, which shows that you are kind of, oh, sorry, it's going down. Okay, so you can go down like that, and that is 40 newtons. So there you're showing that scenario over there. 30 newtons to the right and 50 newtons to the left. Okay, so you show relative size. It doesn't have to be to scale. So as long as I can see, oh, yes, that one is bigger than that one, then that's fine. Okay, now you're going to just get remember, you're going to have a red plane. This is not to say that we have a red direction, because obviously you can see that you have 2 different directions here. But remember, one's going to be positive and one's going to be negative. Let me just get rid of this quickly. So this one's going to be our negative and this one's going to be our positive. You can use the signs of the Cartesian plane. This 25 will be positive and this 40 would be negative. Okay, they're in the red plane. So the red plane is our horizontal plane. Let me just get a nice blue that you can see. Right, so then here's a blue. Okay, and there's my blue direction. So if I now get my resultant, so remember this is just a revision, so I'm hoping you all understanding this. Obviously, it's going to be, okay, so obviously to get to blue, it's going to be plus 25 newtons minus 40 newtons, and that's going to give you 15. Am I right? Is it right? 15, yes, 30%, yes. Okay, so 15 newtons is our blue. Our red, and because it's positive, no, it's going to be negative because it's negative 15. Okay, so plus 25 minus 40 is negative 15. So then we know it's going to go down. Okay, then if I go with my red to show you the red plane, I'm going to have 30 newtons. Technically, you should say plus minus 50. Sorry, I should have done it there. and I get a minus 20 newtons. Okay, so these minuses, when you interpret these minuses, you're interpreting them as a direction. So this actually means 20 newtons left. Okay, and you have to make sure that your final answer does not have the negative in it. Okay, this will then obviously be 15 newtons down. And that would be your final answer over there. Okay, so now you've got 15 newtons down. All right, and we now have 20 newtons going left. So you could imagine this on a new Cartesian plane. Let me just check, is this goals? Oh, thanks, Jim. I can see that. Okay, so now girls, what you should see here is, remember now, only the purple can go inside the quadrants. The blue and the red can go on the Cartesian plane, but the purple will then go in the middle. So if I was to do this like this, remember you go dot, 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 so you're following this. It's like getting a coordinate, I suppose. You're going to get that. Now you notice that I've done this dotted line in red and that dotted line in blue, because that blue line and that blue line are equal in magnitude. They both represent 15 newtons, and these two red lines both represent 20 newtons. And so now I can do my purple, which will then be from there to there. Okay, again, doesn't have to be a work of art, or as long as I can see that you've got your triangles and your resultant is in the right direction. Okay, or not the right direction, the correct direction. Okay, so now you're going to look at this and you're going to say, okay, well, which angle am I going to look at? Okay, we've got a whole load of angles, but now always remember to try and use an angle that is closest to your Cartesian plane. So remember, your Cartesian plane is over there. So you're going to use one of the two, and you can use either of them. Okay. So I think the easiest way to do this is to get that angle. The reason why I choose this angle is because it's the angle closest to my 0. Okay, sorry, I have made this a little bit close to that other one. So let's just block this off so that you can see I'm busy in there. So remember, 0 bearing is up there. Now, I don't know if any of you have, you've looked at the answers at the back there. Their angles are atrocious, absolutely atrocious. I don't even understand what they mean. I can see the angle that they worked out, but it's not a scientific way. They've written the direction for some reason, and I don't know why. It was just written horizontal left, and it's very, very badly written. So that's why I teach you to do bearing, because no matter what you do, bearing is always correct. Okay, and bearing always starts at 0 and goes clockwise all the way around. Okay, so it's the angle that your resultant makes with that 0 line. Maybe that's the key thing that I needed to say here. So you have your resultant, and you've got your angle, the angle that it makes with that north line. Okay, so you've got 0 over here, and you need that whole big angle, and that is the bearing that we're going in. Now, obviously, I can't work out this whole big angle in one go, because it's not a triangle. Okay, and we have to use triangles. Okay, so when we get to this triangle, I'm going to just use this triangle over here. You can use either. Okay, as long as you get this angle here. I'll show you now what to do here. So this angle is the one I'm going to work with. So you should be able to see that, remember, this is a rectangle. We always make a rectangle, and so the opposite sides are always equal. But because I'm using this triangle, I only need those two sides. So I know that that is my opposite, and that is my adjacent side. Okay, I have those two. We haven't worked out the magnitude yet. Okay, so I'm sure you guys have, and it's fine because I did ask you. So I'm just looking at the direction for now. So I have an opposite, and do that. I have opposite, and I have adjacent. So now you think back, oh, what ratio can I use that uses opposite and adjacent? And that is then your tan. Tan theta or x or whatever you label this angle as. Okay, I always use theta. Okay, if it's an alpha, you put an alpha. If they just put an x in the angle, you put an x. If it's an actual, you know, when they go A, B, C, and then they put a little kappa key on the B, you do that. Okay, it's whatever represents the angle over here is equal to opposite over adjacent. And remember, you're going to have to learn that off by heart. Right, so let's substitute. So I know I'm working with the angle, which means, and I know you don't do this in maths, but I want you to put this for science. Shift tan opposite over adjacent. So to get your angle, you shift whatever it is. Okay, you won't get any marks taken off for that. And so what you need to do, I'll write what this actually means. On your calculator, it lands up being that. Okay, and opposite is 20 over 15. Okay, so even when you go shift 10, you see it on your calculator as that. So shift 10, and you immediately see that it goes 10 to the negative 1. Okay, and then you can just go 20 over 15, and we get 53,13 degrees. So that is that angle over there. The angle that they got was, if I just did that, was 36.87, I think. And that was that angle over there, because the two of them together add up to 90. But as you can see, it's easier to work out that angle now, because now I can just add 180 and I can get the bearing, because the bearing is the angle that the resultant line makes with the zero line. Okay, so it only makes a 53.13 angle between the north line, or the 180 line, and the resultant. So I have to add that 180 over there. So plus 180, so 53.13 plus 180 is equal to 233. Oh, don't put an equal. Therefore, 233,13 bearing. Okay, and sorry, that is your bearing. So the bearing is measured from your zero line all the way around, and you can see in which direction you need to go. So, because that's the way we do it. Now, I don't want to, if you had to do this, the geography girls will know that if I had to just put this angle here, if I said 53,13 degrees, I'd have to add something. If I don't add something to that, it looks like a bearing. So you could say that here is my north, okay, and relative to north, the resultant is going west. Okay, so I've picked a north and it's going west. So you could say 53,13 west of north. Okay, you are going 53,13 degrees to that side of north, and that side is west. Okay, can anybody tell me what would it be if I had that angle? So if I use the 36-degree angle over here, how could I say it? I could say I'm starting at west and it's going that angle north. So it would be 36, something north of west. But can you see how the bearing is just so much easier, because the bearing is always the same. It's just an angle and you say a bearing of that. Okay, so, and you can never go wrong with bearing, and they very often give you bearing instead of a west of north or north of west and all of that stuff. Okay, so bearing is the best way to do this. Any questions? Yes.
Could you just repeat what you just said?
Which part?
Which was the west of north, north of west.
The west of north, north of west thing.
Okay, so if you pick this angle, and you can see that this angle is making an angle between the north line and the resultant line, okay, if you're looking at a Cartesian plane. So that means that if I was to start on the north line and move myself to that resultant line, it would be 53.13 degrees to the west of north. Okay, so that's where it is there. If, let's say, this is our alpha, and we know that the alpha plus the theta is going to give us 90. If I'm here and it makes an angle between the west line, because this is west and this is north, and I've used that angle instead, so I've used this angle instead, then I'm starting at west and I'm moving down to my resultant, which is actually north of west. So if I had that angle, I could say alpha degrees north of west. Okay, but it's where you start. It's where which one of the horizontal and vertical lines is it connected to? If it's connected to the west, you start with west. And which way are you going? You're going north, so it's north of west. If you started north and you're moving that way, you're going west of north. But like I said, bearing. Now, tell me, if I had to have worked out alpha, how could I get a bearing? Anyone? I still have to get the angle from naught all the way to there. But now I have this angle instead. This angle line here is 270. So if I took 270 and I subtracted the alpha, I would get 233. Okay. So if you start with that one and you get that angle, you still have to find the bearing of this line, which means that you've got this whole thing here, 270 minus that little alpha, and you get back to that same bearing. Bearing is always the same. Okay, girls, it's 10 o'clock. I'm nearing 10. Please try number 9 and 10 for me again before Monday. Okay, and then if you have questions, I can answer on Monday. Otherwise, I'm just going to carry on with the notes. Okay, so yeah. All right, girls, you better go. Well, it's break, so have a good break.
Thank you, ma'am.
Bye.
Bye.
Bye, ma'am.
Bye.